5, 4, 3, 2, 1.
Hi everyone, welcome to another video by me, the Techie Prepper. Today I'm going to be showing you my design and build of a solar generator. Now you may be asking what a solar generator is. Some of you may know, some of you may not. So basically the concept is you have solar panels either affixed to your house or on your property somewhere, or you can lay them out flat and you feed them into this. There's a battery pack inside and an inverter. So it takes the energy from the sun, stores it in the battery, and then it pushes it through an inverter and out to your AC appliances. The reason I built this is because I looked at the ones available on the retail market, and they were smaller capacity and much more expensive, to be honest with you. I could build this for about a third of the cost for the same capacity. So what I did is I took a toolbox, roll around toolbox. It's about 3 feet by 2 feet by 2 feet tall. And I bought a battery and built it. And then I installed all of the components inside. And what this affords me is 3,360 watts of power available. And I have 4 AC, 15 amp outlets on it. And I have 6 USB ports as well to charge phones and that type of thing. One of the biggest advantages to this type of generator over a fossil fuel generator is you can take this inside. Once you charge it up, you can take it inside. There's no exhaust fumes and that type of thing. Very safe technology, and it allows you to power from inside the house versus outside the house. This particular unit that I built it with a capacity. I live in Florida, as many of you may know, and after a hurricane, if the power goes out, I want to have at least one room with air conditioning all the time because it's very valuable under those circumstances, trust me. This can power an AC for 6+ hours, a 5,000 BTU window unit. Like I said, it's very important you can get some good quality rest or sleep while you take care of other things. It can power my living room for over 12 hours with a big LED TV, a fan, wireless access point, the cable modem, an Xbox. It can keep the party going for over 12 hours under those circumstances. You can also run a kettle on this to boil water if necessary. They make small portable kettles that are about 800 watts, and I can boil water if I need to make it sanitary. I can also cook on this. You can run a rice cooker on it, and I don't know if a lot of you know this, but you can actually cook meat inside a rice cooker as well as rice and soups and stews and that type of thing. They're very handy to have, and you can run them off of that. These freezers behind me, I can run one of those for over 24 hours on this to keep my meat from going bad if necessary. And like I said, you can use this in conjunction with fossil fuel generators. You can run those out back or outside your house, and you power some items with that. Like I do that with my stove and that type of thing, and then I use this to run, like I said, my AC and the living room if I need to, that type of thing. And there's a lot of benefits to having this type of technology. Okay, so let's check this thing out. Here we are on the outside. This is the front. So as you can see, I put the pigtail to input the solar panels on the front. It's got a plastic cap on it, which is off right now. But you can see it's an Anderson style connector. You'd have to change your solar panel connector from the Ford type connector to this. So also on the front is the MPPT. This is actually the display for the charge controller. It shows you the status of the battery as far as the voltage. It shows you the input coming from the panels, if you have any. I don't have it hooked up at this time. And it also shows you what the battery is actually putting out towards the inverter and that type of thing. So it's handy to get your status at a glance. Below that, I flush mounted the inverter on off, so I can turn the inverter on and off without opening the box. The corner over here, as you can see, these are where I put my outlets.
So I flush mounted them. There are power strips that you can flush mount. I put those in, and those are plugged directly into the outputs of the inverter for my AC power. And it also, as I mentioned, provides the 5-volt DC USB. You can see there's a couple holes in it. Those are not accidental. I have 2 on this end and 2 on the other end for cooling. It allows air to flow through, and I'll show you more about that in a moment when we actually go in to the unit. And you can see I have a 5-watt LED with a switch. When I'm dragging this around, if it's at night, it's nice to have a light to see your way. Additionally, I can set this up, and I can surprisingly light up a whole room with that. It's basically a 5-watt landscape light, and that thing will run for over a week with this unit's capability, with the capacity that I have in there. So it provides light at night too. And that's a small draw, so you can run that along with any other loads that you have going at the time. I'll take you to the other side. Whoa, sorry. And hopefully you can see. Here's my other 2 holes. And that'll make more sense in a minute. I have 2 holes on one end, 2 holes on the other. And my original thought was to have it passively cooled, so just air flowing through. The ones on the one end are lower than the ones on the other, above the battery. So the air would come in, rise up, and exit that way. The box is very sturdy. It kind of surprised me. It's very sturdy. It's made of very thick composite material. You can actually sit on it, and it's got the 4 cup holders. How can you go wrong with that? The only thing I don't like about this particular box, and I know I'm not sponsored by anybody or anything, but these handles they're like thin aluminum, and I actually had it open like this. I walked by and I snagged my shorts on it, and it actually bent it. So it still closes a little bit, but I need to kind of fix that. That seems to be the weak point of this. Everything else is pretty stout. The side slides out, and then you just lift this up, and it rolls on the wheels. All right, let's go inside and see where the magic happens. So I'll take you in the order of the process here, how things happen. So as I mentioned, there's the pigtail. I hook up I have 2 315 watt solar panels that power this. So I have 630 watts coming in. And that feeds over to the MPPT charge controller. That's this unit right here in the center. You can see the power goes into there, and then that actually uses an algorithm to convert that power to the most efficient charge current and voltage for your battery. And you can see there's my battery there. It's got a cover on it, which is a good idea for safety issues. If you're going to be working around this with wrenches or screwdrivers, you don't want anything to drop onto that and go across the posts, and you'll have a bad day. You can see the BMS is right there. Maybe I'll do there's a lot of videos out there on building these Life PO4 batteries. So maybe I'll do one later in case anybody wants it. If you do, just request it and I'll show you how I put it together. I have several of them around my house in different functions, different systems. So I didn't mention, when it comes out of the MPPT charge controller, it goes through everything in this is designed with the proper wire sizing for the amperage that's created and used, and also everything has breakers. I didn't use fuses, I used breakers so I could reset them, or when I'm working on it I can cut the circuit. So make sure that you do use the appropriate size wiring and breakers for your application. So it comes out of there, goes through the breaker, goes over, and it actually connects to the battery, and it charges the battery up. That is I mentioned it before, but that is a 12 volt battery, and it's consisting of 4 cells, and it's 280 amp hours. So like I said, that's 3,360 usable watts. I say usable watts, but that's not necessarily true, because it's probably 3,000 I use for planning, if I'm planning on using something and draining it, because there are some losses that come with using the other components. Everything takes electricity to run, so keep that in mind. If it says 3,360 or you have a 1,000 watt hour battery, you may get that, you may not, depending on what you have hooked up and you're using in the circuit. So and then it goes from the battery through another breaker, and then it goes over to my inverter. Not to lecture anybody on inverters, maybe I'll give a comparison in another later video, but if you want to save yourself some headaches, go with a pure sine inverter. They are a little bit more expensive, but when you come across something that you cannot run, then you will be sorry that you didn't put out a little bit more at the beginning. It's especially important to use pure sine if you're working with air conditioners, freezers, anything with a compressor. You want to make sure that you use a pure sine that will extend the life of those units, because the modified sine is very hard on those, especially when they take the initial surge of amperage. So yeah, just keep that in mind. You can use it, depending on your use. If you don't want to use this for those type of circumstances, you just want to use it for tailgating or something like that, for inductive loads, hot plates or something like that, then by all means you could probably get away with that, but just FYI. So like I said, this is a 1200 watt pure sine inverter, 2400 watt peak. For when the compressor or something does kick on, it'll give you a very, very short period of higher wattage. And then also in parallel with that, I have my 12 volt fuse block, and that is run right off the battery. And if you're going to do that, it's very handy, because that actually powers my fan, and it powers that LED exterior light on this. So I can also plug in anything else 12 volts. I just have to pop another fuse in and wire it. Make sure if you do that, you use the appropriate wire size. So I come off of that, and this is where the cooling that I was mentioning before comes into play. So I was going to use passive cooling and have the airflow in through here. You can see I silicone some screen on here to keep any rodents or bugs or anything from coming in, and the air was going to flow up here and then rise a little bit and then go out here on this end. And then I decided, you know what, I have my fuse block, I will buy this DC fan and put it in and force the issue. So when I do close the lid on a sunny day, the sun beats down, it'll get a little hot in there, so this will keep the air flowing and keep everything cool. That's a pretty big factor. Any electronic components, you want to keep as cool as possible, or keep the air flowing around them to provide some cooling. It helps the performance, and it also will help the longevity of the unit itself. So basically I come off the fuse block, and I have a step down there. You can see it. The battery clamps, or I actually just clamp it on. I have some alligator clips, and I clamp it on here when I need to use it. I could solder it on there eventually if I wanted to, but if I want to use that voltage for something else, I have that capability. So what I do is I tilt this up, it goes vertical, and then I put the clamps on the leads here and here, and that forces the issue. The air flows in here, it sucks the air in, blows it over the inverter, the battery, and it creates airflow over the charge controller as well if it's dissipating any heat. And then when it's not in use, I fold it down, and I have a compartment down here where I keep an extra pigtail in case I have to go to a backup solar panel to charge, or I need I keep some wires down there and that type of thing too, an extra cable in case something happens. So you just never know. Or you could keep cookies down there if you want to, whatever you want to put in there, whatever makes you happy. So basically that is the interior of the box and how it's designed and laid out. I will put links to all of these parts below in case you wanted to build something like this yourself. Okay, so let's go through the process. I just wanted to show you load. on this unit, so you can see that it actually does run the AC, and you know, it can do several things at any given time. So what I'm going to do is I'm going to hook it up. I'm going to put my kilowatt meter on there so I can show you the power being drawn from the AC, and I'll show you that this thing in fact does work and works well. First thing we do is we turn on the inverter, and we have power to our outlets. Let's go ahead and we'll turn it on. We'll start it out on the fan, the low fan. It's actually set to max cool for when we turn the cooling on. I don't know if this is a YouTube thing or what, but I'm going to show you a little paper towel blowing in front of it, and then I'm going to also take the temperature to show you that it actually is on cool. So, see our fan is blowing. Let's go to low cool. You can probably hear the compressor kick on there. Okay, it's around 3.16 amps. Which converts, you know, it's AC, so it converts to 374 watts, approximately. It'll fluctuate a little bit, but it's pretty close. And it's starting to get a little cool. It takes a few minutes. Now my plan, what I do with this unit is I actually use it after a hurricane or when we have a power outage, and I only use this small window unit in my bedroom, and I close it all off. It's the master bedroom, so it has the bathroom and everything, and cools that room down just fine. So that is the area where we can all go and get a respite from the heat. It's not meant to cool your whole house by any means, but it will do one room and make it comfortable for you. Okay, we're starting to get a little cool here. Let's see what we got. The temperature in here in the room is, the floor is 87 degrees. It's late June in Florida and it's hot and humid. So let's see what we got coming out. $76, $75. It's getting cooler as we go. It's dropping. So now I'm going to go ahead and turn it up onto high cool. 3.63 amps. 419 watts. So I have seen it spike up as high as 420. I've seen it spike up as high as 450. So that's usually what I budget for. See, the floor is 87. Hopefully you can see that. It's almost 90. It's 88. Depends on what I hit. I will check the 74. I don't know. It's going down 73. It'll get cooler and cooler as we go. But additionally, remember I told you we have the light on the side, so I can turn that on and we can move it around. You can see that the light's on there, so we can run that at the same time. Like I said, this is a very small load.
Okay, now that you've seen the inside of this, I've given you a little tour of the components and that type of thing, and I've shown you what it can actually run. I showed you the AC, but as I mentioned earlier in the intro, it can run other items. You know, it can run heating units. I've actually run a little shop heater on it. You can run rice cookers to cook food. You can run kettles to boil water to make it safe for consumption, that type of thing if you needed to boil water in an emergency. There is a lot of uses for an item like this. As I mentioned, you can get the retail versions. You can buy those, and you're welcome to do that. Maybe I'll put some links below to some of those that I like, that I would consider buying. Or you can build it yourself, and you can save a little money and maybe get a little bit more functionality for what you pay. Thank you for watching my video. I appreciate your support. Links to any of the products covered in my videos can be found below, as well as a link to my website, thetechieprepper.com. On the website, I actually go into a little more detail, showing some basic schematics, more detailed photos, and that type of thing for everything that I cover within my YouTube videos. So don't be afraid to go there and check it out if you're interested. As you can probably tell from the video production, I do this as a hobby. I have a full-time job, but my YouTube videos I put out there to hopefully help people better prepare for emergencies or to endure emergencies with a little more comfort and capability. So that being said, if you are interested in my content or you liked it, please like, subscribe, hit the notification button so you know when I have a new video coming out. And also important is to share with friends, family, anybody who you think might be interested in this content and you might want to help out, like I said, to better prepare for emergencies. So that's all I have for now. Thank you again for watching. I appreciate it. And hopefully I'll have something cool to show you next time. Thanks. Bye.